Okay. All right. All right, welcome everybody. My name is Milton Smith. I'm Senior Principal Security PM for Java Platform Group, and I help to lead the security program. And anyway, this is, if you've seen some Oracle presentations, you're familiar with this here, Safe Harbor statement. Okay, so I talked a little bit about my title here. Who am I? I'm not the only person in security for sure. There's a lot of folks that are involved in security in one form or another. My role as the PM is really to help gather the features that we're going to put in Java, make sure that we're meeting the security challenges that we need to. My background is application programming, and some number of years back saw the need to get into security, and so that's what I did. I think there were a lot of folks at the time who were pretty much firewall guys, systems admins, and application, real programmer was kind of unusual in the security field. I came from Yahoo and joined Oracle last summer. So we're going to talk about, we're going to talk a little bit about security industry challenges. Not everybody has the same level of experience. Some people might be working on coding for security. Other people might have some responsibilities for computers or data center, that sort of thing. So we'll try to level set a little bit, provide a little bit about security history. We'll talk about risk choices a little bit. What are risk choices and risk methodologies, and how do they apply to security? A little bit about security at Oracle, why security is important to us, as well as some of the policies and things that drive our decision making. A lot of folks are, always ask us, why don't you say this, or why don't you tell me Java has this vulnerability or that vulnerability. So this provides some information on why and when and who we communicate to. Then a little bit about ongoing security improvements. So we've got we've made some progress since the last time I spoke on security improvements at JavaOne. So we're going to provide a little update there and share some other new things that we've been working on. So with that, we'll lead into the level setting. So this was some information that I gathered last time at JavaOne, just to try to educate myself. I mean, I've worked on Java for many years, like you folks, but not really understood maybe how deeply it was deployed or widely. So in any case, there are some numbers there. And I try to provide, just so when I throw up things, everybody understands where the sources came from. I put a little reference link on the bottom. So at the end of the presentation, I know there'll be some media that's available on Parlays. I'm guessing that they put the slides there as well. So this would make good material for you if you have to communicate around security to folks in your organization. So there's been a lot of changes since Java was introduced in 1995. At the time, we saw a lot of destruction of data and things like that. Like, it used to be really cool for hackers to reformat your hard drive. Hackers were individual pranksters, and they did more other things like endless rebooting of your computer, just silly stuff. But now, we've really progressed a long ways beyond 1995. Not only in terms of what we can do, with Java technology in our own businesses, but also the nature of the attacks. The level of infrastructure we have, the type of support has led to increasingly sophisticated attacks. And actually, we still do see individual pranksters and things like that, but actually we've seen a lot more of cyber terror, state-funded campaigns, which are hard to prove, but they are usually take the form of being very well organized, and these things, we have noticed. Especially on the uprise. Intellectual property theft. People have discovered, the days of holding up a bank are, don't yield as much as perhaps using a computer as the tool to perpetrate an attack. So we've been hearing a lot about Java in the press, and so anyway. Just why is Java a favored attack vector? So I think if we keep in mind what I showed previously about the numbers, it's widely deployed. But then also, some of the features that make Java useful to us are also useful to attackers, like the fact that it's multi-platform. Usually vulnerabilities have to be written custom for the platform that they run on. If you have a virus on the Mac, we'll say it would have to be different than the virus that runs on Windows. Well, these same great things that you've come to love in Java are also things that people can use against us. The other thing is that we're hearing a lot about, or we're getting a lot of different attacks from on desktops. Java running in the browser has been kind of weak, and a lot of the vulnerabilities that have been remediated are Java running in browsers. Some of the same code that runs on in your browser, of course, runs on your server, but there's a lot of some code, of course, is unique, to running things on desktops or on Java in the browser, like graphical libraries and things that aren't present on the server. So they're two different cases. The other thing is that typically Java running on desktops is not running behind multi-million-dollar data center controls that are very sophisticated, right? It might be your grandma or something, and she doesn't have the same level of controls on her environment. So there's a difference between whether or not a vulnerability is present and whether or not that is being actively exploited. So for something to be exploited, you need the combination of a vulnerability that's present on the machine plus a pathway for exploitation, either a network opening on your network, could be a number of factors. So in order to execute a successful attack, you may have to have more than a single doorway open in order to be successful. So we talked a little bit about the highest risk for Java. Right now, we're seeing applets, web start plugins, things that operate in the browser. Once again, there's due to those factors that we mentioned before, plus the fact that users have valuable information on their systems, like software license keys, financial information like QuickBook files, any number of things that people would find valuable, could be reasons for exploitation. And then the other thing is, of course, sometimes end user systems are either poorly or improperly configured, that sort of thing. People are not as well versed in security as the IT staff at a large company. So for all those things, Java running in the browser is an area that we care about all areas of Java and where it's used and keeping it safe, but the desktops and Java operating in the browser are areas that we're focusing on. So I think right now the climate is much more elevated for security than it ever has been. Security concerns are elevated widely across the industry, and I think One of the things that's a challenge from, I guess, the user or the consumer perspective is that strong versus poor security is really hard to evaluate. You can have two products, one that's highly secure and one product that is not secure at all, and they can both look the same. You know, it's hard to evaluate. It takes special tools and training to evaluate, whereas whether or not an enter button or submit button on a form, on a web form, is there or not is, you know, you can see it. It doesn't take any special training to realize that. So I guess that's the thing, is security is a little more difficult for folks to evaluate. Now, as far as, so we'll kind of talk through some information here about, just kind of silly, but risk methodologies and things, so how we go about making risk decisions. And I guess, you know, it's 4:10 or so you have to bear with me. It's kind of warm in here. We've all had something to eat. It's getting a little later, so okay, here goes. Okay, so do animals drink at a watering hole? Animals with big teeth may be present. Well, the answer is it depends how thirsty, right? If you if you just had a drink not long ago, then of course you can probably wait a little while. But if you haven't had a drink in 4 days, well, or 3 days, maybe you're going to take a chance and go down to that water hole and have a drink, right? So if we continue on. Okay, so everyone treated by a doctor has or will die. Success rate is precisely 0. Do we still continue to visit doctors? And the answer is yes, right? Okay, here's another one. Okay, life is risky. Do we visit the doctor every day for a checkup? No, of course we don't, right? So once again, these are kind of silly, but it's how we use and evaluate risk in our personal decisions. Whether we're going to a watering hole or we're making decisions for either Java or we're making decisions for our data center and security. So our appetite for risk really governs our behavior. And I think in the security maturity curve is that those people tend to be more successful are the people that formalize their thoughts around risk and the decisions that govern their actions. I think, and the point there is that if you focus on the wrong things, then all your efforts don't matter. If you focus on the right things, then a narrowed, focused amount of work can really accomplish a lot. And this is true not only for ourselves, but for decisions that you would make as well. So what's a more practical version of getting away from animals at water holes and doctors? What's a more practical risk process or methodology, thought process? If we use web applications as an example, how important is the application to your business, dollar loss and things like that? Is this a very large application that's very important to your business, or like in the compliance case, does somebody go to jail if the software is not compliant? That's a risk. Is there only inconvenience, or are there some other factors involved? So these are the kind of things that you would ask if you were trying to secure a web application. Do you have any internet-facing application interfaces? If so, those are things that attackers could use on the internet to get access to your systems, or are the interfaces only available inside your data center for employees, say a customer or an HR application or something like that? It's much more reduced surface area. If you have any web data service interfaces, do you have any unauthenticated application interfaces that are visible to the internet? So what that basically means is, if you have an application on the internet and anything that you can see from the internet that does not require login credentials would be open to many people to try and hit on and try different things on. Whereas any page on that application that's behind the login interface can only be seen by people that have an account to your system. So that's more than likely a much smaller crowd than everybody on the internet. And of course, different sort of platforms have different concerns, but the approaches are similar. All right, so let's talk a little bit about security at Oracle. So first of all, why is security important? And just thinking about Java, Java drives your applications. It drives vendor applications, and it drives Oracle applications. So it's really at the core of a big hub there. And it's important to us because, when things happen with Java, I get questions from the outside, but I also get questions from Oracle. Hey, why isn't Java doing this, or why isn't Java doing that? And the reason is they're getting questions from folks that they do business with too. So Java is used in a lot of different ways, in applications and different products that Oracle ships, in hardware devices. It's used in the Raspberry Pi, could be used. So there's a lot of ways in which Java is used, and it's important to Oracle as well. Now, from a policy perspective, policies are interesting in the fact that they govern how we approach things. So a lot of folks often, ask, well, why don't you tell us when there's, something's going on with Java, or it's being exploited or something like that? Well, these are the reasons here. These are available on the internet. These are materials that you can read through yourself. But these are the broader categories of policies around security, communications, development lifecycle, remediation. So from a communications perspective, we have a lot of things that are available that you can proactively be notified. Development cycle, policies that drill into how security touches all aspects of what we do. And then from a remediation standpoint, how we get things fixed when there are problems. So looking at it a little bit more detail on communications, we have security. Security news and alerts are communicated over RSS feeds, and also critical patch update advisories, e-blasts, which are email sort of things, and then blogs like our security blog. And there's a link down there. A lot of times we get asked, why don't we respond to published reports of alleged security vulnerabilities of Oracle products? For one thing, if we were to corroborate or correct an article, then that would let every attacker know that, oh, that thing is true. And now now Java is vulnerable over here. And of course, that would jeopardize everybody that uses Java. The other thing, from an engineering perspective, sometimes people will say, well, this article that this security researcher XYZ published over here, is that the same thing that you just published a security alert on? Or a critical patch update. They want to know that the article is being addressed by the patch that we just put out. And that's very difficult to do because a lot of times these articles do not really contain the engineering details that we would need to evaluate whether or not that actually maps back to the thing that we fixed. So it's generally safer to not respond to that sort of stuff. And as I said before, a lot of those articles are good with generating excitement, but a little short when it comes to understanding exactly what is broken that they're referring to. The other thing is responding to individual reports really forces everybody to track vulnerabilities in social media sites. So if we tell somebody something's broken and around Java security, and then they tweet about it, then everybody has to get on their Twitter and be subscribed to the right accounts and track what's going on with Oracle products through social media. So it's really better to send everybody to the appropriate places where information is communicated at Oracle, and that way everybody receives the information at the same time. It's actionable, it's precise. Anyway, enough said there. So, kind of digging into the other bubble there was security throughout the development lifecycle. So, if you look at this as not a non-specific sort of lifecycle methodology, you can pick your own, but they basically start from a concept stage, analysis, coding, testing, all the way through to delivery. And of course, these little bullets here don't capture the details of what goes on at each level. But the point here is that at least with the way that we build products, and probably most folks that have been doing security for a while, is that you really have to hit security at all the different phases of a project. If you hire a security guy and then you expect, okay, well, we've built and tested this product, now we need to get the security guy's blessing on it to get it out. It just doesn't work that way. We found that if you only engage security testing just at the end, after everything's been finished, there's an incredible pressure to get that thing out. So you have to start early. You have to start in the concept stage and start working your way through. And the reason is if you think about it at a concept stage, for one thing, less scrutiny or more scrutiny. You can understand whether or not something you should focus your time on because it's risky or not. Is this an application that does, we'll say, has compliance requirements or some of those other things that we discussed? Well, then that's an area that you would probably want more scrutiny and you'd focus on it more. Whereas something that's very low risk, doesn't deal with financial information, and has it operates in a deep dark corner of your data center, maybe you don't focus as much of your time on that. Project review. Okay, reviewing architectural choices. Are they using components that have been reviewed and approved, or are they just downloading anybody's open source third-party components and including it in their software? That would be risky. Peer review during the coding process to self-check each other and see how everything's doing, make sure it's what it should be from a security perspective. And then during the testing phase, static analysis, fuzzing, things like that, making sure that you get the right scope and depth of your use cases to test those things that you need to be testing based on the app. And then outside the development lifecycle, we also have different touch points. So we have a global product security group that...
Sorry, just a quick question.
Sure.
What is fuzzing? I thought I knew, but I'm not sure.
Fuzzing is that little feeling that you get when everything is operating properly. No. So fuzzing is, it really is security. Yeah, that's a good point. Not everybody is necessarily a security, maybe has more interest in it. So fuzzing is a type of approach to ferreting out vulnerabilities in your software by trying to generate errors. So typically you'll have a test harness that might hit on certain interfaces trying to cause exceptions and then noticing what sort of results come back. And based on those errors, you might be able to generate malware payloads that cause exploitation of the target. I know that's a mouthful, but tool that generates errors basically, and you can get security information out of it. So GPS, Global Product Security, they're more of a corporate group who has overarching responsibilities for all Oracle products, and Java is one of those. So they can kind of come into the process at any time here. They supervise policies and things like that, and those apply to Java. We have ethical hacking teams who try to beat up on Java in different ways, create some, maybe some testing that we have not tested for in our test use cases and things like that. So sometimes some good things will come out of that, and we'll learn new things that we need to test for that perhaps we hadn't done before. Security training for everybody in the development org. We do a lot of different types of training. There's certain training that's required by Oracle, and then that's very formalized, and you can track metrics and things on that, so we know that nobody slipped through the cracks. And then even on the Java team, though, we have training that goes far beyond that because we have some pretty big security challenges. There's a lot of things that are very platform-centric concerns that you would have on a platform versus concerns that you would have on an application. So sometimes we have to educate ourselves in those. As a matter of fact, at times we have to create our own specialized tools because a lot of times you can imagine if you have a new feature like lambdas or some of these other new features that you've been hearing about, your latest commercial vulnerability scanner probably isn't going to support those new features. So if you were developing a application platform on these things, those tools wouldn't be effective. So you have to develop your own. Okay, so remediation. That was a larger policy area. So we use the Common Vulnerability Scoring System, which is an industry standard developed by National Vulnerability Database and NIST. And how the Common Vulnerability Scoring System works is the higher the number, the more scary it is. Generally, there's some edge cases there, but generally the most scary ones are 10. So if you're looking at alerts and things that Oracle publishes, if you see a 10, then we consider that a very serious vulnerability. There's some other strange ones that you'll see, like a CVSS score of 0. And 0 is kind of strange too. Or if you had 0, then it would, tend to think that, okay, this really isn't a vulnerability. But actually, sometimes the zeros are like not a vulnerability that can be exploited themselves, but they can be combined with other things to penetrate a successful attack. So, for instance, you might have a CVSS score 0 vulnerability that can be combined with another one, and it's kind of like opening one door and opening another door and then getting the pot of gold. That's how a CVSS 0 would be helpful. So if you're seeing those things online on our sites, then you'll know how to think about it. Okay. Yeah. So again, this is getting back to our risk methodologies and how we work on things. This is a tool that we use, or a methodology that integrates into our larger a scoring system that integrates into our larger methodology for doing our risk assessment. So we would classify things during our triage process with a CVSS score, and we would use that score to help us prioritize the remediation process. So if we could work on, of course, if we had 10 things, we'd like to work on 10 things all at once, but if we can only work on 8 things out of that 10 things, then which things should we choose? And that's where the scoring is important to us. Okay, so you thought you knew what a CPU was. Well, okay, you're wrong. So CPUs, if you hear the terminology on some of our sites or whatever, from the security perspective, it's a critical patch update, and those are Oracle security patches. So we have a certain set schedule for CPUs that is announced. October, February, and June are the typical ones. We've been under fire this year with, I'm sure you've read the press and all that. So we published some extra security alerts and things like that, and we'll talk about security alerts a little later. But the security alerts are the other type of patch where if Oracle, if software is being actively exploited, then we get the patch out super fast. That's the security alert versus the CPU, which is more planned, and we generally like to stick to a planned CPU process because the fact that Java is used in many different ways and the test time and things like that, it can be easy to break things. So that's why we have a set schedule. The Java platform CPUs right now are different than Oracle's. We have 3 per year versus Oracle, which has 4 per year. But actually, we're changing that, and we'll be on the Oracle system soon, which is, well, I think we're shooting for October. But the good news there is that from a, I guess from a data center perspective, there's maybe less to plan around, because if you had to plan for your Oracle products CPU and then you had to plan for your Java CPU separately, then there were 2 different times when you have to apply patches, whereas now it would all be the same time, at least when we eventually get there. And the CPU process also does not impact the security alerts, which is the more immediate patching that I was talking about. So here's just some general sort of rules for CPUs. Generally, the CPUs are odd numbered, whereas the updates are even numbered. The CPUs cover all the different families of Java. Some are only available to the public, and some are available on product support and things. I'm not really a support guy, but I get asked support questions at times because people want to make sure that they get the latest security patch. That's another thing too, is that when we find these vulnerabilities, we don't just fix it in the current version of Java. We go back and look at other platforms and older releases and things like that, so we get it all fixed up if it's there. CPUs trigger the auto update process, which is the auto updater that works on the client. We talked about publishing in advance. Some of that has changed for this year. The other thing is with CPUs, because they are security fixes, we don't like to introduce a lot of new functionality. We have changed things up a little this year and have introduced new features in some of our CPUs that are related to security, but we generally don't try to do that because we really try to limit the CPUs to only address the security bugs. That way people have a good degree of confidence when they go to apply these things to their systems that they're not going to break their applications. Okay, so we had talked a little bit about the differences between securing platforms and securing applications. Platforms have a wider use case, where your application is that you write is for one specific use case, and that's your application requirements that you have that it fulfills. But a platform is a little bit different in that we don't really know how everybody is going to use Java. And so testing it from a security perspective can be kind of challenging. And then, of course, some of the language, the new language features and things like that, might prohibit us from really being able to find, because a lot of folks would say, hey, why don't you just use this application scanner on your platform? And, we use it on our application, and it would just find all these Java bugs automatically and get them fixed. And it's just not really that simple with new language features and things like that. So I think this is important. Folks want to know about, restoring confidence. I think the overall plan is really is twofold, right? It's to get Java fixed up, particularly Java in the browser. And that is getting the vulnerabilities addressed for the plugins, the Java applets and WebStart. Adding new features as necessary and getting it done. And then the second part of it is really communicating more to the public. As I said right there, code cannot fix a confidence problem. We need to communicate for that and be a little bit more open, and that's what we're doing, and we're planning more. So we have to make these improvements, fix vulnerabilities, particularly in the plugins, and communicate our progress, which we're starting to do more. And I really think that's how we restore confidence is is doing these things. And eventually, as we do make Java safer and add these new features that people need, and those will be noticed. Okay, so we're going to show a few slides here that I talked about at JavaOne in San Francisco 2012, last year. And so we talked about, we had some features for that addressed drive-by exploitation to defend desktops against phishing attacks and things like that. And we coined a best use before date for JRE security to help defend against out-of-date software on desktops. So these were delivered in Java 7 Update 10 in December. So the best use before date feature there really is a feature that displays a dialog when Java is out of date. Some people don't know, they don't keep Java updated, and a lot of the problems that we're seeing right now aren't necessarily because we didn't get the vulnerability fixed in Java, but it's that people are largely out of date with their software. So if you're out of date with your software, well, we do publish the CPU materials so people understand what vulnerabilities are being addressed by a release, and if there's things that you find on the internet and all that, it provides a roadmap for exploiting old systems. So people that have old systems, I guess operationally, people that run data centers have to make choices, right? Or between operational stability, not being the early adopter and causing your systems to break, or being secure. Being secure would, the priority there would be to update and always stay on the latest update. But from an operational perspective, you don't want to break things either. So these are some choices that data centers have to make for individual users. They tend just not to want to keep their systems up to date. And so in any case, out-of-date software is a big concern, and that's why we developed these features here. So previously, it was very difficult to disable Java in your browser. You had to uninstall it, or there was no easy platform-independent way to do that. So in Java 7 Update 10, we added a little checkbox in the Java control panel that desktop users can either enable or disable the plugin. So you'll find that in there now. There's also a security slider there that you can change the value to and have all the way from like low to very high. The other thing that we're doing is the other thing that we're going to do is encourage people to uninstall older JREs by having a uninstaller applet that's available on the web, and we will eventually want to transition to having probably an uninstaller or to clean up the old versions of Java at the same time you're installing. But for now, we have a page out there that at the end of the install process, people will be taken to help them get their old versions of Java cleaned up on their computer. So some of the features yet to come here that we talked about that have not been delivered yet are configurable IT security policy and some more frequent security feeds around blacklisting and security baseline updates. So the security baseline update would be the process for how the desktop software or the plugin understands when it's out of date and needs to be updated. So the other thing that we're doing that is new, and that's out there right now and you can see, is so during JavaOne last year, I went to a lot of the different security sessions as the security guy, and I counted the number of sessions that were there, and it was impressive. There was a lot of interest in security, and not just from Oracle people talking about security, but just from the community at large. So I worked with the JavaOne team, and said, hey, why don't we turn this into a legitimate track, just like we do with core technologies and some of these other things? Because I know when I submitted my presentation for JavaOne, it wasn't really clear to me which track it belongs in, and I think I chose core technologies. But so in any case, we've added a track, and so I'm going to be the track lead for the security track. I've got some support from industry. Some of the OWASP folks are going to join me and help to vet out these things, as well as some senior members from the Java team. The links are out there for the security track, so if you want to submit some papers for a presentation that you'd like to see, feel free. We'll take a look at them. What's the security track going to be about? Well, yeah, it's going to be about coding securely. We're going to do some of that because everybody can understand what the new techniques are, and we can all share those. Open source projects, crypto and hashing, lesson learned, case studies, some of these things here. And this isn't necessarily to limit what you could submit for the JavaOne security track, but it's just to kind of give you some ideas, I guess, to stimulate some ideas. I think the thing is there's a lot of things that we can all do in security, and security is definitely an Oracle concern, but it's also a community concern, and so this is the purpose for this track, is to really to reach out and stimulate ideas from the community. So it would be interesting, of course, to coders or architects or security practitioners, systems admin, perhaps business leaders that have concerns about their data centers. And then, of course, you can submit right now. The other thing that we're going to do starting April is Java has supported code signing, but it really, I would say it is more or less optional. But going forward, we're going to make some changes in April that encourage code signing. And so I guess there's been some confusion with folks around what encouraged means. I've had folks, well, what does that mean? Does it mean you're required, or does it, what does it mean? And so what we're going to do is we're going to make some changes without getting too much into the details, but basically if your code is signed, your applet, your plugin code, then the messages that a user would see in order to accept that applet running will be very minimal. Code, again, this is risk, getting back to what I said earlier in the presentation. Code that has been signed is, if a user has accepted that this program is going to run, and it's been signed, then it would be considered low risk. So the message is very minimal, and also has a little checkbox kind of thing that says, go away and don't show me again. If code is unsigned, we're still going to let it run, but the message that's presented to the user is a little scarier, because it's coming from something that the identity cannot be established. So that one would require, maybe a multi-step sort of click to accept, not just a click here and go away sort of thing. So in any case, this is scheduled for April, and so the action item here is if you have applets and things like that, you should look at getting them signed. So this is call to action. These are things that we can all do. So if you have vulnerabilities and you want to report them, it's not clear to everybody how to do that, but Oracle has an account. You can send your report to secalerts_us@oracle.com, and we'll take a look at that. We'll review it in a triage process, figure out where that vulnerability needs to go, and that's for all products, not just for Java products. If you have new features that you'd like to suggest, there's a link there that you can do that. And since there's been a little confusion on the CPUs, And we've done some change-ups here. I just went ahead and listed what we have on the plate so far, so you can see what that is. And then I made a note for October that we're transitioning to Oracle's CPU schedule, which takes us from 3 CPUs a year to 4 CPUs. And then you can find the details on the CPUs there if you have any questions. Yeah, so I get a lot of questions on Java platform support. I don't get a commission. I'm more on the development team. But I get those questions because people want to know, okay, well, I've got Java 6, and how do I get support, and what do I need to do, or I have some vendor software and the vendor's not recertifying it on the newer version of Java. There's a lot of legitimate reasons why people cannot upgrade. But in any case, these are just some high points of the 3 different options that they have available. And
it's not options. It's if you buy, there's only one support contract. You get a support contract, and the service you're getting depends on how old the software is. So if it's within 5 years from GA, you get the premium service. If it's 8 years, then slightly worse service, and sustaining. Don't hold your breath, but if it's really, really important, we'll help you.
Okay.
And I do receive a commission.
Okay. Well, so this slide needs a little vetting. But in any case, I hope we helped to answer any questions right there that you may have had. Moving on. Okay, so we do have a root certificate program where if you would like to get your root in the Java Trust Store, then there's a process for doing that, and you could submit your request and it will be reviewed. And there's, of course, all the different rules and things like that are available on that link. So, okay, so what are things? So we've talked a lot about Oracle's responsibilities and things that we're doing with Java security, but what are things that you can do? Okay, so for end users, you can keep your JREs updated, keep your auto update turned on, practice defense in depth, your virus scanners and things like that. If you have firewalls, use them. Don't just turn them off because they interfere with your gaming. And then for developers, there's things that developers can do too. So for example, keeping your software on the latest version of Java. That will enable everybody that's using your product to be able to patch quickly because that version of Java will be supported. So keep your programs up to date, recertify them on the latest versions of Java. Sign your applications like we talked about. Validating untrusted data. Okay, make sure follow like OWASP guides and things like that if you have questions. So I'll just kind of speed through here. Yeah, very good resource there, OWASP, Online Application Security Project. They have a lot of things for engineers resources for how to secure your web apps and things like that. Once again, the Java security track, JavaOne security track. And then, of course, our shameless plug for jobs here. We're always looking for good people. That's all I have for you. And if there's any questions, you can just bring them up here at the table. Thank you.